Hello friends, how are you? I hope you would be fine. Today my topic is about introduction to machine learning, that what it is. So before moving to my topic, I'll request you to please subscribe my YouTube channel and don't forget to watch my previous videos, okay? So moving to my topic. First of all, introduction. We'll go after reading these applications on introduction. Most readers will be familiar with the concept of web page ranking, that is the process of submitting a query to a search engine which then finds web pages relevant to the query and which returns them in the order of their relevance. See example figure 1.1 for an example of the query results for machine learning. That is, the search engine returns a sorted list of web pages given a query. To achieve this goal, a search engine needs to know as you can see, which pages are relevant and which pages match the queries. Such knowledge can be gained from the several sources: the link structure of web pages, their content, and their frequency with which users will follow the suggested links in a query, or from examples of queries in and combination with manually ranked web pages. Increasingly, machine learning rather than guesswork and clever engineering is used to automate the process of designing a good search engine. A rather related applications is collaborative filtering. Okay. Internet bookstores such as Amazon or video rental sites such as Netflix uses information extensively to entice users to purchase additional goods or rent more movies. The problem is quite similar to one of the web page ranking. As before, we want to obtain the sorted list. In this case of articles, the key difference is that explicit query is missing, and instead we can only use past purchase and viewing decisions of the user to predict future viewing and purchase habits. The key site information here are the decision made by the purchase habits. The key site information here are the decision made by the similar users and the collaborative nature of the process. See figure 1.2 for example. For an example, it is clearly desirable to have an automated system to solve this problem, thereby avoiding guesswork and time. An equally ill-defined problem is that the automatic translation of documents at an extreme. We would aim at fully understanding our text before translating it is using a curated set of rules crafted by the computational linguist well versed in two languages we would like to translate. This is rather artist task in the particular, given that task is not always grammatically correct, not the document episode understanding part itself a trivial one. Instead, we could simply use examples of translated documents such as proceedings of Canadian Parliament or the multilingual entities, United Nations, European Union, Switzerland, to learn how to translate between two. You can see that between two, a taste machine learning, a taste of machine learning languages. In other words, we could use the example of translations to learn lower translate. This machine learning approach is proved quite successful. Many security applications, example, you can see that for access control we use recognition of as one of its component, that is given for the photo or video regarding or person recognize who is a person, who is person is this. In other words, the system need to classify the faces into of many categories: Alice, Bob, Charlie, or decide that it is unknown face. A similar yet conceptually quite different problem is that the verification here. The goal is to verify whether the person in question is who he claims to be. Note that differently to before, this is now a yes or no question to deal with the different lighting conditions, facial expression, whether a person is wearing glasses, hairstyle, etc. It is desirable to have a system which learns features are relevant for identifying a person. Okay, another application where learning helps in the problem of named entity recognitions. So this is enough for today's topic. Time to go. Goodbye. Meet you in the next video.